Welcome back to episode 11 of our Explainer series. Today, we're diving into something totally wild, an incredible application of computer science where we're tearing down a quiz that actually builds itself as you take it. If you've ever wondered how next-generation architectures are completely rethinking the very boundaries of data and logic, well, you're absolutely in the right place.
We're going to take you right under the hood today. We'll kick things off with the self-building quiz, look at the core patent architecture, dive into the parent node, the user answer event, how it spawns child script nodes, and finally, we'll wrap up with the evolving tree database. Let's get right into it.
All right, section 1, a self-building quiz beyond static data.
So, picture this. You log into an educational quiz, right? But it isn't just pulling static data from some distant server. It's a living database that actually adapts and grows its own structure based entirely on your answers. Now, you might be wondering, how does a database programmatically modify its own structure without a developer constantly redesigning the schema? It's a huge question, especially when you think about traditional software where the data and the instructions to interact with that data are kept completely separate. Usually, changing a database structure means an admin has to manually redesign the whole thing. But how do we bypass that entirely?
Let's move to section 2, the core patent architecture. Anatomy of U.S. Patent 12,664,142.
To find the answer, we've got to look at this blueprint. It outlines a hierarchical tree database where the nodes are actually active, not passive. This brilliantly illustrates the stark contrast between your standard passive databases and this new active system. On the left, your standard database just holds information. It literally just sits there waiting for an external app to do the heavy lifting and thinking. But on the right, in our patented active database, the nodes are alive. A single node holds both the data properties, like the actual text of a quiz question, alongside the function properties, written as executable scripts right there inside the node.
So the crucial takeaway here is this concept of dynamic growth. You can kind of think of this database as a living tree that sprouts brand new branches in response to environmental stimuli, like a simple click from a user. Because these nodes contain their very own execution logic, they don't need a developer holding their hand. When an event happens, the database just programmatically self-modifies.
Moving right along to section 3, the parent node question, the root of the interaction.
Let's start breaking this down at the very beginning of the interaction, anchored by what the patent calls the parent node. If we break open this parent node, think of it like a little folder containing two absolutely vital pieces. First, you've got a JSON file securing the data properties, stuff like the exact text of the question, a timestamp, and a child count. And sitting right next to it, a JavaScript file. This file holds the action. It contains function properties like display prompt to actually show the text and make child, which, well, we're going to see that in action in just a second.
Section 4, the user answer event, triggering growth.
Okay, let's zoom in on the exact moment the user hits submit. This is the critical event. This user input isn't just dead data being passed over to a server. It acts as an active trigger. It's an environmental stimulus that wakes up those embedded scripts in the parent node and forces the database tree to respond and adapt. The event carries a specific data item, the student's answer. And because the parent node is an active event handler, it catches this input and immediately executes the script instructions defined in its JS file to process exactly what just happened.
Which brings us to section 5, spawning child script nodes, expanding the tree. Guys, this is where the magic literally happens. The patent maps out this dynamically spawned flowchart logic so perfectly. It's a swift 3-step combo. Step 1. At process block 210, it instantiates a brand new child node right in the interpreter environment. Step 2. At block 230, it generates its specific script modules. It is physically creating new JSON and JS files for this child. And finally, step 3. At block 240, it creates a link back in the parent script module so the whole tree stays connected, updating the parent's child count and namespace addresses.
Now, if we take a peek inside this newly sprouted child node, we find it has beautifully encapsulated the user's specific answer in a timestamped JSON file, right alongside its very own JavaScript file. This child node is not just a row in a table. No way. It's a fully functioning programmatic entity. Its JSON file logs the exact question and the user's specific answer, giving it a unique namespace address, like #1 for the first child. The JS file? It contains an application-specific validation function called isAnswerCorrect, which simply returns true or false based on what the user inputted.
You can almost think of this like digital cell division. To give you a really satisfying taste of the actual engineering kernels making this happen under the hood, the syn function acts as the synthesizer, creating the key values for the newly synthesized child node. Then the tie function acts as the anchor, securely linking it back to the parent scope. This is the underlying kernel logic that allows the database to safely and dynamically self-modify.
Finally, Section 6, the evolving tree database, a living architecture. When we zoom back out from this single parent-child interaction, the implications for the entire database architecture are just massive. Because the script execution path and the database retrieval path are now exactly the same thing, this design completely eliminates the translation layers that usually sit between data storage and general-purpose execution. In traditional computer science, we call this friction the object-relational impedance mismatch. You normally need these super heavy driver libraries and parsing overhead just to get the application to talk to the database. But here, the database nodes literally are the application.
What you should really take away from all this is that this quiz isn't just some app talking to a database. It's merging the application layer and the database layer into a single, self-evolving runtime kernel. It is a unified, event-driven hierarchy that physically expands its directory structure with every single user interaction. The nouns and the verbs, the data and the instructions, they're co-located in the same nodes. It's a highly optimized setup that perfectly mimics the hierarchical way we humans actually think and categorize information.
It leaves us with a truly fascinating thought. If this technology turns databases into living, adapting organisms that physically grow in response to user inputs, what entirely new, unprecedented forms of software engineering are waiting to be grown tomorrow? If a simple educational quiz can programmatically build its own architecture on the fly, imagine the implications for complex, adaptive systems in the future. Thanks so much for joining me on this deep dive into the recursive educational quiz. Keep questioning the architecture, and I'll see you in the next explainer.